Hi, this is Miss Merced, and I'm going to go over your lesson on expanding. So here we're asked to expand these binomials, and it's basically the same binomial, a plus b, except we're going to expand it to the 0 power, the first power, the second, third, and fourth. Just like I could pick any number, I'm going to pick here 3. And if I raise it to the 0 power, any number raised to the 0 power turns into 1. So that is the same case as this. A plus b, this binomial, when it's being raised to the 0 power, it only just turns into a 1. And then if I continue with the number 3, when the number is raised to the first power, it's just listing that base number once itself. And here is the same idea. When you have this raised to the a plus b to the first power, you're just listing it once. Then here, a plus b squared. Again, if I go back to the 3, if I do 3 squared, that's like saying 3 times 3, which 3 times 3 is 9. Okay, here I'm doing the same idea. I'm doing a plus b squared, a plus b times a plus b. And when I do that, I'm now multiplying it out. I'm going to FOIL. So a times a is a squared. A times b is a b. B times a is a b. And b times b is b squared. If I add these together, add like terms, I get a squared plus 2ab plus b squared. So that would be my answer for the a squared, a plus b squared. Moving on to the next one. Looks like I'm running out of room here. So let me move this down a little. So this is a plus b to the third power. And a plus b to the third power, if we go again to our example 3, the base 3, 3 to the third power is like saying 3 times 3 times 3. Well, we know 3 times 3 is 9, times another 3 would be 27. So that's all we're doing. We're doing a plus b times a plus b times a plus b. Now, I already figured out what a plus b is. That's like doing this. 3 times 3 is 9, then timesing it by 3 again. Okay? I already figured that out. That was the one previously. So I'm just going to use this in replacement of a plus b times a plus b. And then I only have to multiply one more time. Okay? So I like to usually list this first. So a plus b. And then here I'm going to use the trinomial that I figured out in the expansion in the line above, okay, in the problem above. So here is now my expansion that I'm working on to get the a plus b to the third power. So a times a to the second power is a to the third. A times plus 2ab is 2a squared b. A times b squared is b squared. AB squared. I'm done with the A. I've multiplied it to every term in the second parenthesis. So I'm going to just cross it out because it helps me keep things in order. Now that I'm going with B, I'm going to multiply B with everything inside the second parentheses. So this B times A squared is BA squared, and it's 1. I'm actually going to list it vertically and line it up with the other ones that I could add it to. And then b times 2ab is, let's see, 2ab squared, because b times b is b squared. And this is a 1. And then b times b squared is b to the third. So I've vertically lined them up, and now I'm going to add like terms. And this just helps me to know which terms to add together. So a to the third plus 3a squared b. My coefficients get added, but the exponent stays the same. This is still just a to the second and b plus 3ab squared now. So the b, the coefficient stays the same, plus b to the third. So that is my answer for the original expansion of a plus b to the third. The last one is now a plus b to the fourth, a plus b to the fourth power. And what I'm going to do, and that's just saying, again, with the 3, if I was going over here to the 3 to the fourth power is like saying 3 times 3 times 3 times 3. 3 times 3 is 9, times another 3 that I just brought down is 27. And then times another 3 that I'm bringing down is, let's see, 27 times 3 is 1, 2, 6, 81. 81. So if I was to ask to solve 3 to the fourth power, all I would do is say 3 times 3 times 3 times 3. And I would get 81 as that answer. Okay? Same idea here. You're doing a plus b to the fourth, a plus b times a plus b, there is no to the fourth, times a plus b times a plus b. I would not suggest trying to multiply a plus b with this term and this binomial and this binomial and this binomial. That will get really confusing. I would first multiply these together, then add another one, then multiply another one in, and then once I get that, then multiply the last one in. I already kind of did that here. So this last expansion that we created is basically all these 3 multiplied together. So I just need to multiply the last one in. So I'm just going to rewrite the expansion a third plus 3a squared b plus 3ab squared plus b to the third. Okay, and then I'm going to multiply this. A times a to the third is a to the fourth. A times 3a squared b is 3a to the third b. A times 3ab squared is 3a squared b squared. And then a times b to the third is ab to the third. I'm going to cross this out, and then I'm going to start with the b, and I'm going to try to line it up with the other terms that I could possibly combine it with. So b times a to the third is this one right here, which is 1a to the third b. b times 3a squared b is, let's see, 3a squared b squared. b times 3ab squared is, let's see, 3ab to the third, and then b times b to the third power is b to the fourth. So this is using your laws of exponents, and that's how we're building it. That's how the exponents are getting bigger, because we're multiplying the bases that are the same and adding the exponents. Add like terms, a to the fourth plus 4a to the third b. I'm only adding the coefficients. That's the only thing that's changing. Plus 6a squared b squared plus 4ab to the third plus b to the fourth. And that is the final answer for the expansion of a plus b to the fourth. So I rewrote it as here. This is the final answer. If I just wrote it without the actual problem being given, I got the 1a plus 1b is the second expansion, the a plus b to the first power. Then here is the third expansion we were asked to do. Here's the fourth expansion we were asked to do. And then here's the last expansion that we were asked to do. Okay, thank you guys.